Hi, Sheetal. Oh no, can you hear me? I hope I'm not muted again.
Hey, yeah, hi, I was
You're there.
muted. Sorry, I can hear you now.
That's all right. Hey, Mike. Actually, hi, Mike. being in person is new for Containers from the Couch. Thank you all for sticking with us. This has been just so much information today, and I hope everyone's learning a ton. This next session was talked about in the very beginning. Bob was mentioning it for IPv6 support in EKS, and Mike and Sheetal here are here to talk about it further. Like, what does it mean to get IPv6? What does it mean to have pods that have that giant long string? Something about grains of sand can now be part of IoT. It's kind of crazy. So, Mike, you had an introduction earlier. So, Sheetal, introduce yourself. Tell us what you do.
Hi, I am Sheetal Joshi. I am a developer advocate on EKS team, and I'm very excited. I know it has been a long day for everybody here listening, and I hope the demo gods are with us at 5 p.m. EST, and hoping to give some great insight into IPv6 and what we have implemented here.
Yeah, sounds great. So I know Mike has a couple slides to kick us off, and then we have a demo of IPv6 running in EKS clusters with pods. So Mike, go ahead, let us know about the update.
All right, so IPv6 update. It feels like IPv6 is, most companies, is next year's project, and it's been that way for the last, I don't know, 10 or 15 years. But at EKS, it's this year's project. We've been hard at work throughout 2021 on adding support for IPv6, and we'll show you that with a demo coming later, and we'll be launching this pretty soon. So we're going to walk through some IPv6 basics, how it works in the VPC, how it'll work in EKS, and then do the demo. Why IPv6? I think this graph makes it pretty clear why we need it. When IPv4 was invented back in the 70s, we didn't consider all of the connected devices and IoT devices and the proliferation of devices that require an IP address that was coming. And so today, public IPv4 addresses are a very scarce resource. And really, to work around that, we've done all kinds of crazy private natting workarounds that's really just ugly and difficult to work with. And the solution to that is IPv6, which is a massive public space of IP addresses. And it really addresses all of the shortcomings with v4. Adoption of IPv6 has certainly been accelerating over the last several years. 5G, 4G, 5G networks have been driving it. A lot of countries now have pretty substantial v6 internet utilization. You may notice, if you run a ifconfig command on your home network, you may notice that you get v6 depending on your internet provider. So it's becoming more and more common, and it's definitely the future of addressing. And additionally, one of the things not is well known is you actually get slightly better performance and lower latency with IPv6 compared to v4 in most regions of the world. Now, how an IPv6 address looks may be a little foreign to some of you used to the dotted notation of IPv4. IPv6 uses hexadecimal to represent an address, and it's broken up into 3 parts. The first part is the global routing prefix, and this generally is managed by your internet service provider, or in the case of AWS, this will be managed by the VPC if you choose to use Amazon-owned space. The next part is the subnet identifier, and then finally the network interface identifier.
No, wait, Mike, I was told IPv6 had no subnets. What are you talking about?
IPv6 has subnets. We're still doing subnets. We're still doing private networks, and we'll talk about all that. It just works a little differently, and it's much cleaner.
Do I get a slash anywhere in here? Like, I mean, there's colons now. It's just like more dots and letters. I don't understand.
We'll get into some of the details. I think when Sheetal does the demo, she'll show you exactly what it looks like in a real-world v6 scenario. So the size of IPv6 versus v4, it's a number that's hard to comprehend for humans. I think if you gave every atom on planet Earth a v6 address, you could do that 100 times over for another 100 Earths. The other stat is the Earth is 4.5 billion years old. If you were assigning IPv6 addresses at a rate of 1 billion every second, since the Earth was formed, you've only used a trillionth of the IPv6 space. So it's a very large number. It's unlikely to run out in any of our lifetimes. So to summarize, with IPv6, you get a much larger address space. And there's also some built-in authentication, encryption, and better performance. So it really addresses all of the limitations of IPv4. So now how it works in Amazon. VPC has supported IPv6 for a number of years now. And then it supports it in dual stack mode. So with the VPC, today you cannot yet do IPv6 only VPC, but you can do v4 and v6 dual stack VPC. So you can add a single IPv6 CIDR block to a VPC. You can either bring your own or use an AWS assigned one. For subnets, you get, it's a fixed length. It's a /64. There's the slash
there you
were
go.
looking for.
Thank you.
So you can get up to 256 subnets per VPC. And then /28 is an individual address assigned. And actually not shown on this slide, but how EKS is going to work is the recently launched prefix assignment feature from VPC, where you can assign a /80 to every node. So different sizes, different slashes, and we'll cover this more.
How many pods does that mean if I have a /80?
I think a /80 is 13 trillion addresses, if my math is right. So,
I don't know of a node size that would fit that many pods, but okay.
Yeah, I don't think you're going to run out of addresses for pods with the /80. And just to show you here the comparison, if you look at a node or an instance in a dual stack VPC, you'll see the different addresses, one for v4 and one for v6. Okay, so this is a common question in IPv6 because it's a globally public address space. One of the first questions is, what about private subnets? How do I protect instances in a subnet? And the answer to that in VPC land is the egress-only internet gateway. It's similar to a NAT gateway, however, importantly, no additional cost. And if you add this to your routing table in a private subnet, traffic can egress from the VPC, but external traffic can't hit your v6 addresses in that subnet. So that's how you do private v6 in the VPC land. And then all of the normal features that you're used to in a VPC, network access control lists, security groups, all that still works. You're just, the source address in the rules is going to be different to target IPv6 addresses versus IPv4. But everything you're used to in VPCs, all of that still works. So putting it all together in a VPC, today it's dual stack mode. Resources can communicate over v4 or v6. They're independent, configured separately. For public networks, you're going to route the default route to the internet gateway, just like you do in public subnet with v4. For private, it's a little different. Instead of routing to a NAT gateway, you're going to route to the egress-only internet gateway. Okay, so that's all the background. How is it going to work in EKS?
Now, IPv6, this is Kubernetes. Shouldn't this be like 8? Like, at least, I'm sorry, it's a bad joke. It's been 6.5 hours. I was thinking IPv8's just, but it's okay. We can keep going and just ignore
we didn't make it all the way to 8.
I was like, we can go with branding here. I mean, like, even 7 fits inside the Kubernetes space because of the original name, but 8 would be nice. But I guess we'll just stick with 6.
We'll stick with 6 for now. So let's talk about how Kubernetes networking works. Kubernetes networking is a flat layer 3 network where every pod gets its own IP address, and pods have to be able to communicate to each other without any network address translation. And that makes it very easy to port applications from a VM-based world into Kubernetes, but it has a lot of IP address requirements, and many VPCs with IPv4s aren't equipped to handle that. We've heard from a lot of you that you're running out of the private IPv4 space in your VPCs. And so how v6 is going to work in EKS, I think Bob mentioned this morning, but it is not Kubernetes dual stack. Every pod will not get a v4 and a v6 address. Instead, every pod will get a globally unique IPv6 address assigned per pod. But if your pod needs to talk to something outside of the cluster, whether that's some public website that doesn't support v6 yet or some AWS service that doesn't support v6, the nodes are still dual stack, and the traffic will be routed through the node. So you really get the best of both worlds. You can adopt IPv6 and EKS without needing to have the rest of your dependent services support IPv6 already. And so this is coming soon. We're in the final stages of testing and rolling this out, and we'll show you how it works in the demo. Just a couple more slides here. So in v6 networking, I mentioned this a little bit, but every worker node will get a /80 prefix, and you can see that ENI prefix on each node. And then when a pod gets scheduled to the node, the CNI plugin will take an IP from that prefix and wire it up to the pod. If a pod is talking to another pod on the same node, that'll just go through localhost. But if it's talking to a pod on another node, that'll actually go directly over IPv6 in the VPC. So I mentioned pod to pod. Pod to external IPv6. This is where it's much simplified compared to v4. In v4, you have to route through a NAT gateway before you talk to something in the public internet. With v6, if the public internet endpoint already supports IPv6, it's just a direct route. So no more complicated NAT routing setups. Whoops.
I don't know why I never even thought of that, where if IPv6 is at the destination, there is no NAT between me and it. That's okay. That just, I don't know. I just dawned on me, and now I'm just freaking out about that. That's crazy.
It's drastically simplified.
Right.
On the other hand, if the endpoint you're talking, so if you make the DNS call, if the endpoint supports v6, it'll get the v6 address back. If it doesn't, and it returns a v4 address, then we have to go through this route shown here, where the traffic's routed through the worker node, then through the NAT gateway, then to the address. So a couple more hops, but this makes it much easier to transition to v6 and EKS, versus if we just did IPv6 only, then everything your pod needed to talk to would also have to be v6. Okay, I'm going to hand it over to Sheetal to show a quick demo of how this is all going to work.
Okay, thanks, Mike. Just in the interest of time, I have already created a best practice VPC for EKS cluster. So what we are seeing here is VPC with IPv6 enabled.
Can you make that bigger for us?
Okay.
One more time. Thanks, good. Thanks.
Okay, cool. And we have 4 subnets that we have created, 2 private and 2 public subnets. Is it all visible for everybody?
I can see it okay.
Yep.
Okay, and each of the subnet, as Mike previously mentioned, you can see /64 IPv6 header assigned and /24. So you cannot just have IPv6 header for a subnet today. So we both have IPv4 and IPv6. This is just the requirement from the VPC currently. And let's go back to VPC here. The route table that we see here, let me show Okay, so if you see, all of the IPv6 traffic is routed to egress only internet gateway, while it is through the NAT gateway for the private subnets. Let me hop on to, the egress only internet gateway is just similar to NAT. You don't do anything separately. It's free of cost, and then the same, cost applies for the egress internet gateway. Let me jump back to the cluster creation here. Let me see. Okay. Can you see the command that I'm sharing? Okay.
I can see the terminal, but I can't read it at all.
Okay. Is it any better?
Keep going.
Cool. Okay. So I have already provisioned EKS.
Can you make it a little bigger, Sheetal?
Okay. So I have already provisioned an IPv6 cluster. As you can see, the cluster provision itself is very much similar to IPv4. Just you will see some extra flags saying Kubernetes network config IP family as IPv6, right? It's not like a dual stack IPv4, IPv6. We are just going with an IPv6 model. So you will see Kubernetes network config as IPv6. Let me share the cluster, which is already provisioned via the console. Yeah, as you can see in the networking configuration.
Make that bigger too.
Sorry.
Sorry.
Cluster IP address family as IPv6, and the service IP range is from the VPC IPv6 CIDR range that is assigned. All of the server endpoint access models, the public, private, and the public still applies. You can actually provision the cluster endpoint in all 3 different modes that we support today. That doesn't change. And the add-ons, I don't have anything here, but the add-ons are going to be supporting the IPv6. There are some of the add-ons which might not be, but that the list will be published soon. From the cluster, let's go to the nodes, understand the nodes. The nodes that have been provisioned are connected to the cluster using the IPv6 endpoints. So let me share the nodes. Okay. And so they use the IPv6 address to communicate to the cluster endpoint. And let me take to the EC2 console here. So as we talked about, as the nodes join, we still use the VPC CNI in the background. And what VPC CNI, what we do here is we do leverage the prefix assignment mode. And as the nodes join the cluster, we do assign one single IPv6 prefix, which is /80. And this is the significant difference from what happens in the IPv4 land. We do not need one single prefix is sufficient enough to run the large cluster and with multitude of the pods in it. So the IPv prefix assignment happens during the instance launch time, and one prefix is enough. So we do not do any more EC2 control plain API calls. It's just at the launch time we do assign one prefix. So this is the IPv6 prefix assigned to the primary ENI of a node, and the pods will be assigned addresses from this prefix. So let's jump on to understanding how does CNI differ, right? We still allow pods to be communicating to IPv4 endpoints because we do understand not everything is IPv6. Everybody is still trying to get on to IPv6, but that's not the reality. So how does it work, right? So let me log into one of the node.
Can you make it bigger again, Sheetal?
Sure.
Keep going.
A few more times.
Okay. Let me know if this is better.
I can read that.
Okay. So internally, we do the CNI chaining, and for egress only IPv4, every node gets the host local CNI plugin and from a local IPv4 CIDR range. And this IPv4 CIDR range is not going to be visible or routable outside of the node itself. It's just chained along with the regular CNI plugin. So let me go to one of the pod that I have already run. So what does it look like within a pod, right? So the pods get ETH0 for the primary interface. There is an IPv6.
Pinch to zoom that one too.
Okay. The pods get the IPv6 address along with the IPv4 address as well. The pod-to-pod communication on the cluster, it is always IPv6, and anything trying to communicate via the IPv4 will be blocked. So let's understand. Let me schedule an application and then see how do we provide an ingress access to our application, right? So let me open up. Okay, so I'm just deploying a sample game application, and the service that you see here, here we are using the ingress mode, and when we provision an ingress, it provisions an ALB, internet facing, and you will mention, okay, I want a dual stack IP address. What does that mean is an ALB which is provisioned will have an IPv4 endpoint as well as an IPv6 endpoint, so that IPv4 outside applications or a user or your browser should be able to communicate to your application, as well as an IPv6. And today we only support target type IP mode. We are working on an instance mode, but it should be all seamless for you. So let's see how it all works. Let me apply. Okay, so let's see if we have the deployments. Okay. Yeah, so let's give a couple of minutes for this ingress to come online.
And you mentioned you're using ingress there in your spec,
Yes.
But you didn't mention you're using the AWS load balancer controller, which provisions that load balancer from as an ingress type, which is neat. Which, if people haven't been using the new load balancer controller ever since the 2.0 release, you can deploy ingress to an ALB directly from that controller. So
Correct,
it used to be the ALB controller. Now it does a lot, load balancers for services, NLBs, ALBs, ingress, all of that stuff. So the new controller, just shout out, we didn't even have a time for a session today for it, but has done a lot of stuff in the last year.
That's correct. Thanks for reminding about that, Justin. So let's go back and check how it all happens. So let's see the load balancers, whether the target groups have been registered here. Sorry, it's session expired.
Always expires right when you're doing the demo. It knows.
Yeah. Cool. Yeah. So the listeners, if we go back. So this is the other effect of zooming in too much. Okay, so you will see all of the IP addresses. These are the IPv6 addresses of the pods that get registered, right? So this is all the magic of Elastic Load Balancer that basically is doing for you in the background. So let's check the connectivity. And before I go there, let's confirm the pod IPv6 address. Let me exec into one of the pods that we just provisioned. Sorry, I just.
There it is.
Okay, you will see the new pods that are scheduled also have an IPv6 address along with the IPv4 from the host local range that we have configured. I am gonna perform some IPv6 connectivity as well as the IPv4 on just to see how does it resolve from a pod itself. Just for a test, I have provisioned an S3 bucket just in an IPv4 mode. And we should be able to reach that S3 bucket from within the pod. Let's see, do a sample curl from the pod. Yeah, so I'm just saying use IPv4 mode here, and from within the pod, it's able to resolve to an IPv4. It's all dynamic. You don't have to do anything specific extra to figure out whether you're reaching an IPv4 or IPv6. The connectivity just gets dynamically routed for you. Let's see if our load balancer is provisioned now, and I'm going to try resolve to the same IPv6 load balancer endpoint from within the pod. Sorry, I am within. So when I try to do it with the pod, it is an IPv6, so it should call to the IPv6 address. Yeah, so we are able to basically reach an IPv6 endpoint from within the pod also. And if I try to basically go resolve an IPv4 endpoint from within the pod, that shouldn't be allowed. IPv4 connectivity from within the pod will be disallowed. And I think I should be able to get to my application from my IPv4 browser. I do not have IPv6 enabled, so it should still work, and you can ingress into your application from outside.
So everything here at the pod has IPv6, but everything is just transparent. You can route in and out.
Yes.
IPv6, IPv4.
Correct. Yeah.
That's great.
And because I'm actually trying to connect from my browser, which is an IPv4, so it just resolves to NLB IPv4 endpoint to the IPv6 targets pod in the backend.
Wow. That's really cool. So that's coming soon for IPv6 support in EKS. I'm sure we'll have a launch blog and some more information once that's available. And yeah, that's in. Mike, Sheetal, anything else to add?
No, I think that was a great demo. Just to be clear, this is all still coming soon. There'll be a new version of the load balancer controller coming to support v6. There'll be a new version of the CNI plugin, and then there'll be updates to EKS itself. So we're getting close. Final stages of rolling this out. Look out for the announcement soon.
Sounds great.